And I'm Morgan, your Newtonian expert.
We are here to talk to you about the physics behind soccer.
We will teach you how speed, velocity, and acceleration go well with Newton's 3 laws of motion. In order to really know and understand Newton's 3 laws of motion in soccer, we must know what speed, velocity, and acceleration are first.
Speed is the rate of change in motion or how fast something is moving.
This is Rachel running down the field.
There are 3 types of speed. First is constant speed. Constant speed is when an object covers the equal amount of distance in equal amount of time. Second is instantaneous speed. Instantaneous speed is the time at a given point. Third is average speed, which is distance divided by time and is labeled meters per second.
Rachel ran 10 meters in 2.84 seconds, so she got an average speed of 3 meters per second.
Velocity is the speed of an object in a particular direction.
This is Rachel kicking the ball northward.
Finally, acceleration is the rate of change in velocity over time.
And finally, in soccer, when you pass the ball back and forth, there's a change in speed and direction.
But Morgan, do you know why a soccer ball slows down after you kick it?
Why?
That's because of friction. Friction is a force that opposes motion.
Oh, I see.
Friction plays a huge role in soccer because after you kick it, it slows down and wow. Because there is friction between the grass and the soccer ball.
Like when you kick a soccer ball. And it may cause the soccer players to slip.
One way to increase friction is to wear soccer cleats. It allows you to grip the field and to run faster.
Newton's first law of motion states that an object at rest tends to stay at rest, while an object in motion tends to stay in motion, unless acted upon by an unbalanced force, also known as the law of inertia. An example of Newton's first law would be when a soccer player hits the ball into the net. The ball is at rest, and then Rachel is the unbalanced force that will then have contact with the ball. The ball will then go into motion. When gravity and the unbalanced force such as the net hits it, the ball will then go back to rest. Another example of Newton's first law would be when a soccer player throws the ball in from the sideline.
Oh, I see. It has motion in the air, and when an unbalanced force hits it, such as gravity, it will go down and eventually stay at rest.
Exactly, Rachel. Newton's second law states that force equals mass times acceleration. The more force you have, the more acceleration. And the more mass you have, the less acceleration.
Here we have a soccer ball and a kickball. The soccer ball weighs more, so if we roll both of them at the same force, the kickball will go further because it has less weight. Another example of Newton's second law is when Morgan kicks the kickball and the soccer ball with the same force. The kickball will go further because it has less weight.
Newton's third law states for every action there's an equal and opposite reaction. So the ball will hit the crossbar and the crossbar will hit the ball with the same force it went up with.
Another example of Newton's third law is when my head will hit the ball and the ball will hit my head. So as we have learned today, velocity, speed, and acceleration play a huge role in Newton's 3 laws of motion.
Newton's first law states an object at rest tends to stay at rest and an object in motion tends to stay in motion unless acted upon by an unbalanced force, also known as the law of inertia. Newton's second law says that force equals mass times acceleration. And Newton's third law says that for every action there's an equal and opposite reaction. And that's the physics behind soccer.
Mathematics expert.
And players to slip. One's gonna suck. Oh, sorry. In motion tends to stay in motion unless acted upon. In order to know
One way to increase friction is to wear soccer cleats. I'm Rachel, your keynote.
I gotta be. Okay, ready, set, go.
I'm saying